right, we're taking a look at 10.1 arcs and sectors. Okay, so example 1, we need to relate the central angles and the arc measures. We need to find what the measure of arc AB and the measure of arc ACB are. Okay, so the first thing we're going to do is talk about some different types of measures. So first is our central angle. And our central angle is this center angle right here. So that would be angle APB. That's my central angle. Next is my corresponding arc. And that's the arc that corresponds to that central angle. So the corresponding arc would be this AB. Next, we'll look at our minor arc. Okay, the minor arc is the smaller arc, so the smaller AB arc is our minor arc. Then is our major arc is the next. Okay, our major arc, that's the larger arc. And that's going to be the entire outside arc here. And we would name that arc ACB. Okay, so now we want to find the measure of AB. So that's what the question's asking for. So we want to find the measure of AB. Well, we know that our corresponding arc has the same measure as the central angle. So if my central angle is 95 degrees, that means the corresponding arc to it has a degree of 95. Okay, then we want to find the measure of arc ACB. And if I know that arc AB is 95, I can take 360, subtract off the arc that we already know, that 95, and that's going to give me a measure of 265 for that arc ACB. Okay, let's look at the triad. All right, so we have circle W. We want to find the measure of arc XZ. So we are looking for this arc right here. Well, its central angle is 115, and the corresponding arc then also has to measure 115. Okay, next is the measure of XYZ. So XYZ is the rest of that exterior. So we would take 360 and subtract that 115 to find the measure of XYZ. So we would end up with a measure of 245 degrees for that arc. Okay. So we kind of just figured out that our arc measure has the same measure as the corresponding angle, the central angle. Okay, and that's what this is telling us in our arc measure. We know that if they're telling me that angle JPK is congruent right here to KPL, then the arcs would also be congruent to each other. Okay, so example 2, how do you find the length S of an arc measured in degrees? Okay, to do that, we would take our arc length, divide that by the circumference, and then set that equal to the arc measure, which we would have in degrees, divided by 360. Okay, so if our arc length is S, we know to find circumference, it's 2 pi r. Our arc measure, we're going to call N, and then put that over 360. Okay, now we want to solve this for S. Okay, so to solve this for S, I would need to multiply both sides by 2 pi r. That's going to get me S equals N over 360 times the 2 pi r. Okay, so that's how I would find the measure in degrees. Okay, next question is, how do you find the length S of an arc measure in radians? So now we're looking at radians. Okay, we know that radians are the measure of the central angle. Okay, so then to set that up, we would have our arc length. We would put that over circumference. And then set that equal to the arc measure, but this time it would be radians instead of degrees. Okay, and it wouldn't be over 360 this time, it would be over 2 pi. Okay, so then to plug in what we know that arc length is S. We know to find our circumference, we would take 2 pi r, set it equal to our arc measure, that's theta, over the 2 pi. I want to get S by itself, so I'm going to multiply both sides by 2 pi r. Okay, that's going to leave me with S equals theta r, because this 2 pi is canceled out with this 2 pi. Okay, let's look at the triad. So now they're telling us we have a radius of 4. What is the length of an arc that has a measure of 80? And we want to round to the nearest tenth. Okay, so we're going to use that formula that we just came up with for our degrees. So our S equals N over 360 times 2 pi r. We're going to take this formula that we just came up with, and we will plug in the information we know. So we're looking for S, that length. We know our measure is 80, so N is 80. And I know that my radius is 4. Okay, I'll go ahead and calculate. I would get 16 over 9 pi, which is going to end up about 5.6. Okay, B. In a circle with a radius of 6, what is the length of an arc that has a measure of pi radians? And we're going to round that to the nearest tenth. So this one we're going to use what we created for our radians, which was theta r. Okay, we're going to plug in pi for the theta, and our radius is 6. So that's going to end up getting us 18.8. Okay, next we're going to look at arc length. Okay, the length S of an arc of a circle is the product of the ratio relating to the measures. Okay, so these are again what we just kind of talked about. We created those formulas to help us find the central angles when we're dealing with degrees and with radians. Let's look at our first example. We want to apply the arc length. We want to find AD, arc AD. So we're looking for this arc right here. Okay, so I want to find the measure of arc AD. And I can find that because I know that all of the arcs added together would add up to 360. I know that this arc is 73, this would be 43, and this would be 104. So I can subtract all of those from my measure. Let me try to move this. Move these down so I've got some space here. Okay, so now I'm going to subtract all of those from the 360. And that's going to give me my measure for arc AD. So that would get me 140. But they asked us to express it in terms of pi. So now we need to convert that to radians. Okay, so I'm going to plug it in. I'm going to take the arc that I just found, 140, put it over the 360, multiply by the 2 pi r, which our radius, they told us right here, is 4. Okay, now I can calculate. Okay, so that means my arc AD in radians is 28 over 9 pi. Okay, let's look at the try it. All right, we're looking at circle Q. We want to express the answer in terms of pi. What is the length of JK? Okay, so we're dealing with radian, so we're going to use our radian central angle formula, which is the S equals theta r, and now I'm just going to plug in. So my theta is going to be that 3/4 pi times r, which is 5. Once I calculate that, that's going to get me 15 over 4 pi. All right, let's look at B. What is the length of HK? Okay, so HK, we are looking for this exterior arc here, the bottom arc. I know that the outside of a circle is 2 pi, and I can subtract the arcs that I know. So I know that I have a 1/3 pi arc, and I have another 3/4 pi arc. Okay, so this is a 1/3 pi arc, and this would be a 3/4 pi arc. Okay, once I calculate that, I'm going to get 11 over 12 pi. Okay, so again, I'm going to plug that in to find S. So my 11 over 12 pi would be the theta, and then the radius of 5. And that's going to give me 55/12 pi. Okay, example 4, relate the area of a circle to the area of a sector. A sector of a circle is the region bounded by two radii and the intercepted arc. What is the area of the sector MQN? Okay, so now we're dealing with degrees, so I'm going to use the formula where I plug it in for degrees. So I would have my n, which is 78, so those degrees of 78 over to the 360 times pi r, which is 10 squared. That's going to give me the area of just that shaded segment. Okay, once I calculate, I'd get 65/3 pi. So that tells me that my area for MQN is 65/3 pi centimeters squared. Okay, let's look at our try it. A, what is the area of the sector? So again, we're dealing with degrees here, so we're just going to plug it in. So 165 over the 360 times pi r, which is 3 squared. I'll calculate that and get 33/8 pi. Okay, B, we want to find the area of this sector. So again, we're going to take our degrees, so 59 over the 360, multiply it by pi r, which is 10 squared. And once I calculate, I would get 295/18 pi. All right, let's look at example 5. We want to find the area of a segment of a circle. A segment of a circle is the part of a circle bounded by an arc and the segment joining its endpoints. What is the area of the shaded region? So we're just looking for that little piece of shaded region. So the first thing we want to do, we've got a couple of steps here. We want to find the area. And we're finding the area of that entire slice in that circle. Okay, so my degrees would be 60 over 360 times pi r, which is 8 squared. Once I calculate that, I would get 32/3 pi. So that 32/3 pi, change to a highlighter here, is the area for this entire section. That's not what I'm looking for. I'm only looking for that shaded green section. So I have to keep going. Okay, next I'm going to use the Pythagorean theorem so that I can find the area for the triangle that is right in here. Okay, so we're going to find that area next. All right, again, Pythagorean theorem. We take our two sides, add them together, set them equal to the hypotenuse. Well, I need a 90-degree angle, so I'm going to drop down a height here, and I'm actually going to create two right triangles. And I know that if this side was 8, this would have to now be 4, as well as this. and we're trying to find the height, which is going to be called x. We're just going to call it x. Okay, so now I'm going to take my smaller side, 4 squared, add to it the unknown side, and then my hypotenuse, which is the 8. Okay, go ahead and simplify. I want to get rid of that square, so I'm going to take the square root of both sides. And that will reduce to 4 square root 3. Okay, so I have found the height of that triangle essentially, so now I can find the area of that triangle. Okay, so to find the area of that triangle, my formula for area of a triangle is 1/2 base times height. So I'm going to take 1/2 times the base, which my base of this is going to be that 8, times the height, which is what we just found, the 4 square root 3. Once we calculate, we would get 16 square root 3. So that is the area of the triangle. Now I can take the area of that entire segment and subtract the area from the triangle. Okay, so the area that we found for this segment is right up here. I'm going to bring that down. And I'm going to subtract from that the area of the triangle, which we just found right here. So that's going to get me 5.8, and that is centimeters squared. Okay, let's look at the try it. All right, we want to find the area of the segment. Okay, so first we need to find the entire area of the segment, including the portion that's not shaded. My radius is 10, so that's going to get me 25 pi. Okay, I want to find the height of this triangle, and I'm splitting a 90-degree angle in half, so I'm creating a 45, 45, 90. So if I create a 45, 45, 90, I know that this side would be congruent to this side. So I'm going to set this up as 10 squared equals h squared plus h squared, because I don't know what either one of those measurements is. So I end up with 2h squared, divide by the 2. So I'm going to end up with square root of 50 once I simplify, which is also 5 square root 2. Okay, so now I can plug that in to find the area of the triangle. 1/2 base, which would be the 5 square root 2 doubled. So 5 square root 2, 5 square root 2. When I combine those, I would get 10 square root 2. And I multiply that by the height, which was also 5 square root 2. Okay, once I calculate, I'm going to end up with 50 for the area of the triangle. Now I just need to subtract, so take the area of the segment, subtract the 50, the area of the triangle, and I would get 28.5 feet squared. Okay, let's look at B. Doing the same thing again. It's going to get me 10 pi. I want to find the area. Okay, that's going to give me an area of 7.347. So now I can subtract those, my 10 pi, subtract my 7.347. That's going to get me 24.1 meters squared. Okay, so we want to see if he has enough paint to make his coasters. He's trying to make 18 coasters, and each coaster is being cut out of a circle that is 8 inches in diameter. Okay, so let's plug this in to find our area. Our degrees are 72 out of the 360 times our pi, r, which is 4 squared. Once I calculate that, that's going to get me 10. So the area of each of those wedges is 10. His paint covers 200 inches squared. I'm going to subtract the 10 inches squared that each coaster takes. So we can make 20 coasters out of each jar of paint. Okay, the original question was whether he could make the 18 coasters. And yes, he can make 18 coasters off of 1 jar of paint. B, he puts decorative tape around the edge of each coaster. How much tape does he need for each coaster? Okay, so essentially we're trying to find the perimeter of the outside of each of those coasters. So around each coaster, so if I've got my little watermelon sliced wedge, I would have a radius, which is 4, and a radius, which is 4. And then my arc measure, which is 72 degrees. Okay, so I would have my radius of 4 plus a radius of 4 plus that arc measure, where we take our 72 degrees divided by the 360, multiply that by the 2 pi r, which is 4. So once I calculate, that's going to get me 13. So he needs 13 inches of tape per coaster. Okay. All right, let's look at the try it real quick. All right, what is the area and perimeter of sector QNR? So QNR, we want to find the area and the perimeter. So first we're going to find area. Okay, this missing arc measure would be 100. Our radius is 6. So my area is 10 pi, or roughly 31.4. We also want to find our perimeter. finding the perimeter of this segment. So if we have one radius of 6, this is also 6. So I'd add the radiuses of 6 together, and then I need the arc measure. Okay, so that's going to get me a perimeter of 22.5.